Hey folks, today's topic is solving trig equations part 1. We're going to get into trig equations part 2 next unit. Get a little more complicated where you might have to substitute or factor to solve them. But today is pretty straightforward. I want to talk first about what's the difference between solving and evaluating. So solving versus evaluating. When I'm evaluating something that's trigonometric, evaluating looks something like sine of pi over 6, okay? That's what we're trying to find, sine of pi over 6. So what do I have and what do I want? I have, and what do I want? So I have the rotation or length, or angle maybe is the best way to say that. It's probably the way that we think about it the most. We have the rotation or the angle, and what do we want? We want the side length of the triangle. So we would draw a triangle at pi over 6, then we would figure out which side we wanted because of sine, and then we would evaluate from there. When you're solving, it's like saying sine of what angle is 1/2. So you see up here, this is what I'm trying to figure out. The answer would be 1/2. That's the piece that I want. Down here, I would have to work to try to figure out what the angle is. So what do I have versus what do I want? I have the side length of the triangle, and I want the rotation around the unit. I'm just going to say rotation or angle. I don't like that length part. So you're trying to find the angle. Maybe I should just say angle instead of rotation. Whatever. Okay. So solve the given equation for all solutions from 0 to 2 pi. And we say 0 to 2 pi because there could be infinitely many solutions. And you think about it, let's say I wanted you to figure out where is the angle that gives you a y value of 1/2. So where could I draw a triangle that would have a y value of 1/2? So the y value would have to be 1/2, so that would be a 30. Well, I could go here, or I could go another lap around to 360 plus 30, which is 390. Or I could add another 360, and that would be right. Add another 360, that would be right, over and over and over again. So I'm going to have us narrow down just to the solutions that are in the unit circle. All the solutions that are between 0 and 2 pi. All right, so first thing I do, there's two ways to look at this. I look and say, all right, first of all, where is sine positive? I don't care that it's 1/2 right now. I just care that sine is positive. Sine and y behave the same way in the unit circle. So sine and y would both be positive in those two quadrants. Then I would look at my special right triangles, and I would say which one of these three special right triangles has a sine value of 1/2. In other words, has a y direction or y side of 1/2. 1/2, 1/2. Okay, there it is. This one has a y. I'm not looking in this direction because this is the x direction. The hypotenuse is none of the directions that we care about. We only use that if we're doing SOHCAHTOA. So the 30-degree triangle has a y value of 1/2. So I usually go up here and I write myself a little note that I'm looking for the 30-degree angles that are in these two quadrants. Now, because our solutions lie between 0 and 2 pi, 2 pi is what kind of units? Those are radians. So our answer should be in radians as well. So now I'm going to go to my unit circle, and I'm going to try to find in quadrants. I checked here and I checked here, quadrant 1 and 2. Who are the 30-degree angles in those? That's pi over 6 or 5 pi over 6. So theta equals pi over 6 or 5 pi over 6. Those are my solutions. Those are the two angles that if I rotated to those angles, I would have a sine value of 1/2. I'm going back up here and change that to angle for next year. Go back up here, change this to angle. All right, let's try another one. So cosine of delta is equal to negative square root 2 over 2. I don't care about the square root 2 over 2 part right now. I just care that cosine is a negative. So cosine is negative. That's basically saying x is negative. X is negative in these two quadrants. Now I go to my special right triangles. Which one of these special right triangles has a cosine or an x side that's square root 2 over 2? Boom. That's the one that we want. So that was a 45. So now I want to find the 45-degree angles that are in those two quadrants. So go to your unit circle. Go to quadrants 2 and 3. The 45s are 3 pi over 4 and 5 pi over 4. So delta is equal to 3 pi over 4 or 5 pi over 4. If you don't like the Greek letters, you can change everything to x if you want to be boring. If you want to change everything to theta, you can be boring if you want to. All right, let's encourage you to pause here and try to do part C. All right, let's see how you did. So sine of psi is equal to negative square root 3 over 2. So sine is the y, and y is negative there and there. I go to my special rights. Looks like 60 degrees is the same as a sine. That 60 degrees has a sine value of square root 3 over 2. So you've already taken into the account the negative part. So you don't, as long as you find the 60 degrees in these two, it'll automatically come out to be negative. So psi is equal to, no, that's phi, my bad. Phi is equal to, who are the 60s? That's 4 pi over 3 or 5 pi over 3. Cosine of omega is equal to 0. So that's basically saying where in the unit circle is cosine 0. So this is a little bit different. We can't do check marks because x is supposed to be worth 0, not worth a positive or a negative. So where on the x-axis, my bad, let me try that again. Where in the coordinate plane do you have a location where x is equal to 0? Well, there's two spots. You could have here, or you could have it here. Either one of those places on the unit circle, straight up or straight down, have x values that are 0. So just because it doesn't let you draw a triangle, or it's not one of the special right triangles, I should say, just because it's not one of the special right triangles doesn't change that you can still find locations in the unit circle that have that x value. So I get pi over 2 or 3 pi over 2. Let's have you try the next one. Pause if you haven't. Okay, sine is -1. Now this one's interesting. Everything up to this point had two places in the unit circle. There is only one place where sine is -1, where y is -1. And that would be that location right there. So sine is -1, only there. So lambda would be equal to, what would that be, 3 pi over 2? Now, could I answer negative pi over 2? Not according to my restrictions. I gave you between 0 and 2 pi. I mean, if I didn't have that restriction there, you could write that down. But if I didn't have that restriction, you'd have to write down plus 2 pi n. You'd have to write all the possible times that it would end up being that same value. Okay, so tangent. Now we finally get to something interesting here. When is tangent equal to 0? Well, let's think. What do we know about tangent? Tangent, sine over cosine. Tangent is also y over x. So this is essentially saying, it's saying tangent is the same as y over x. And we want to know when that's 0. Well, is 0 okay or no good? 0 is okay. So we're trying to find the places where y is 0 and x can be any number. We just k stands for any variable that you want to think of. So I'm going to go back to my unit circle. Where do we have y values of 0? And then we don't care about the x. So y is 0 here and here, these two locations. So sigma, lowercase sigma, would be equal to, this is 0 or this is pi. Now you could also write 2 pi and pi, if you want to call this 2 pi. Technically that wouldn't fit, but I'm going to let it slide because this is supposed to be less than 2 pi, not including 2 pi. So, you're being a little bit off the mark if you write 2 pi, but I'm okay with either 0 or 2 pi. I'd let that slide. Tangent is equal to negative square root 3. Now this is where things get kind of tough. So let's first look at what's happening when tangent is a negative. So tangent is a negative wherever, because tangent's y over x. So for y over x to end up being negative, y and x must have different signs. So this is where x is negative and y is positive. This quadrant is where x is positive and y is negative. So I know it's going to be those two quadrants. What I don't know is which tangent triangle, which one of my special right triangles, when I do tangent with it, would end up with that weird square root 3. Now you should recognize these from last lesson, or 2 lessons ago, I guess it would be. You should recognize those, but what's tough is remembering, is it going to be a 60 or is it going to be a 30 that's going to generate those? So let's go through and actually calculate it out. So let's just pick one. Let's start with the 30. So my right angle and my reference angle is 30. So from the 30, we can start to fill in some sides. So across from the 30 I don't need a different color yet. Across from the 30 is 1/2. Adjacent to the 30 would be square root 3 over 2. Now we're supposed to be doing tangent. So tangent is opposite over adjacent. Nobody in the world can divide by fractions, so we flip and multiply. That's going to put the 2 and the root 3. What's going to happen to those 2's? They'll cancel, so I get 1 over root 3. What's wrong with having a root 3 on the bottom? Well, you can't, so I'm going to times it by root 3 over root 3. 1 times root 3 is root 3. Root 3 times root 3 is 3. Now, before we go any further, let's take this and add this right to our unit circle. You don't have to do all that work, but let's go to the 30-degree triangle. The 30-degree special right triangle has a tangent of root 3 over 3. So I'm going to go over here. What would be a good color? I guess I'm going to do it all in this sort of light purple. So for the 30-degree, tangent equals, what did we just figure? Tangent is the same as square root 3 over 3 for the 30-degree triangle. Now, what can it be? Let's just do the 45 right now. Tangent is y over x, or opposite over adjacent. What's root 2 over 2 over root 2 over 2? Yeah, it should be a 1. And then finally down here for the 60. Now let's go back to our notes and try to squeeze that in here. So this time I'm drawing a 60. Opposite, square root 3 over 2. 60 adjacent, 1/2. Tangent is opposite over adjacent, square root 3 over 2 over 1/2. Nobody can divide fractions. So instead we flip and multiply. 2 over 1, the 2's cancel, and we're left with just root 3. So now we can go back to our unit circle. For the 60-degree tangents, the same as square root of 3. So you don't have to recalculate those every time. I don't mind putting those on the unit circle. We've done it once. We don't have to keep calculating it over and over and over again. If you haven't done it yet, this is your reminder. Add to the unit circle. Add to the unit circle. So, coming back to this example, tangent is negative square root 3. So the tangent that's square root 3 is going to be the 60. So this is a 60. So the 60 degrees that are in those two sections, we would get xi is equal to, what would that be, 2 pi over 3? Or 5 pi over 3? Yeah, 5 pi over 3. Let's have you try the next one. All right, let's see how you did. So I'm going to first figure out tangent is positive. That means the places where x and y have the same signs. The triangle that would give me a tangent of square root 3 over 3 would be my 30 degree. So epsilon would be equal to the pi over 6 or 7 pi over 6. And then last, before we get into the reciprocal trigs, tangent of zeta is undefined. So we have to first think about what would that look like? What kind of tangent? Well, first of all, what do we know about tangent? Tangent the same as y over x. And for tangent to be undefined, where would the 0 have to be? Would it have to be okay or no good? It have to be no good. So we want to find the places where x is 0. X is 0 here. X is 0 here. So what's that? That's 90 and 270. So zeta would be equal to pi over 2 or 3 pi over 2. So when I'm dealing with the reciprocal trigs, and that's the second part of the notes here, I always take it and turn them into the regular trigs. In other words, I reciprocal both sides. So if I have secant of delta is equal to negative 2, I can just do the reciprocal of both sides, and I would then have something that's not one of the reciprocal trig functions. So secant is the reciprocal of cosine. Now I'm allowed to turn this into cosine as long as I reciprocal the other side. What's the reciprocal of negative 2? Would be negative 1/2. And now this problem becomes one of these problems up here. Cosine is negative, check, check. Cosine is 1/2, that's with the 60. So who are the 60s in those two sections? Delta would be equal to 2 pi over 3 or 4 pi over 3. Cosecant of alpha is equal to square root of 2. Now you can deal with it as is, or what I recommend is to turn it into one of the other trig functions first. So who's the reciprocal of cosecant? That would be sine. What's the reciprocal of root 2? Well, I've got to make that into a fraction, so it would be over 1. So it would become 1 over root 2. Bad news, right? We can't handle 1 over root 2, but we can rationalize it. So I'm going to times this by root 2 over root 2. And we get 1 times root 2 is root 2. Root 2 times root 2 is just 2. So now I have the equation sine of alpha equals root 2 over 2. Sine is positive. check, check. Sine is root 2 over 2 with a 45. So I'm looking for the 45s that are in that section. So alpha would be equal to pi over 4 or 3 pi over 4. Let's have you try the next one. Secant of mu is equal to negative 1. So the reciprocal of secant is cosine equals the reciprocal of negative 1. Well, negative 1 is one of those weird numbers that when you reciprocal it, you end up getting the exact same number. 1 reciprocaled is 1. Negative 1 reciprocaled is still negative 1. So this is essentially asking me, where is cosine negative 1? Cosine and x are the same thing. And there's only one place where cosine or x has a negative 1 value. So mu is equal to pi. Cotangent of rho equals square root of 3. Can't do it. Can't do it as it is. So we're going to think about it in terms of its reciprocal. The reciprocal of cotangent is tangent. Now, if you want to, you can reciprocal this and go through all the work, or you can eventually memorize that root 3 over 3 and root 3 are reciprocals of each other. I mean, here's the work. Root 3 would be over 1. When I reciprocaled it, it would be 1 over root 3, and then I would clean it up. So I'm just going to cut to the chase. I know the reciprocal of root 3 is root 3 over 3. Tangent is positive, check and check. Tangent is root 3 over 3. We just did this for a 30. So who are the 30s in those two sections? Rho would be equal to pi over 6 or 7 pi over 6. Cotangent of psi is equal to negative root 3 over 3. I'm going to reciprocal that. Reciprocal of cotangent is tangent. The reciprocal of a negative is still negative, folks. It's not going to change the signs. But we just talked about this. So the reciprocal of root 3 was root 3 over 3. So the reciprocal of root 3 over 3 would be root 3. Tangent is negative when x and y have different signs. Tangent is square root of 3. We just did that one up here when it's a 60. So that would be 2 pi over 3 or 5 pi over 3. And the last one is just to remind us about how reciprocals of undefined and 0 work according to each other. So remember the reciprocal of undefined. So right now this is saying cotangent. Well, what's cotangent? If tangent is y over x, what's cotangent? X over y. This is saying x over y is undefined. In other words, x over y is no good. That's what this statement is saying right now. Well, when I reciprocal that, I get a different statement. The other statement, the next statement would say if I reciprocal this, the reciprocal of cotangent is now tangent. And what would tangent, I guess I should try to draw, is equal to, what's the reciprocal of undefined, would be 0. So as a reminder, what's the reciprocal of x over y? Y over x, which is nice because that's tangent. But now this is no longer no good. This is now okay. So if I want my y over x to be okay, that means it has to be the places where y is 0. Y is 0 here, y is 0 here. So, oh boy, that's pretty nasty. Equals 0 or pi. And again, if you wanted to use 2 pi instead of 0, I'd be okay with that. All right, a lot going on here. This is a whole nother page. of the test is solving. Evaluating is one page, and then solving is another page. So half of the test is this idea of relating special right triangles to the unit circle. Good luck.